Today we're going to learn how to write code using the Standard Template Library's list class.
Hello, I'm James Helfrich. The list data structure is not used as often as vector, and I think that is because most people really like the square bracket operator associated with a vector. However, if you don't need to have random access to something, in other words, if you only need to access the beginning, the end, and traverse through it linearly, then the list data structure is probably the right choice for you. This video will demonstrate how to use the list data structure.
There are many constructors to create a list: the default constructor, the copy move constructor, and we can also fill it a variety of ways. Let's take a look at each one of them. All right, in order to use the list, we have to first #include list, and that's going to access the Standard Template Library's list code. Now, the full name of the list class is std::list. We have to specify the data type, int, and I'll call this L. And when I run this, I'll have a list of size 0. Now, of course, if I say using namespace std, I don't have to do std::list. Notice the size of 0. Okay, I can also create the list a different way. I can initialize with 4 elements. In this case, the default constructor for my data type will get called. It's an integer. That means I'm going to have 4 zeros. Sure enough, I have 4 zeros. But you know, I don't have to fill them with zeros or the default value. I can fill it with anything I like. In this case, I'll have 4 99s. And there we go, we have 4 99s. Okay, let's see what else I can do. My personal favorite, the initializer list. So I'm going to fill the list with the values 2, 4, 6, and 8. Once again, this can be 4 elements in the list, and the values 2, 4, 6, and 8 will be filled in. There we go. Now, I can also use the copy constructor. So I'm going to take an old list, I'm going to say list source, and then I'll have a destination list, std list int l destination. And let's see here, should I use initial list? Yeah, I'm going to do the copy constructor there. And now, both the source and the destination will have 4 elements, 2, 4, 6, and 8. All right, now I can also move the elements from the source into the destination using std move. This will mean the destination will have those 4 elements, 2, 4, 6, and 8, but source will have nothing. And sure enough, we take a look at this. Source is of size 0, but the destination has my 4 elements. Okay, I have several different assignment methods: the assignment operator, the assignment method, as well as swap. Okay, so we'll start by creating a list of a collection of elements. And I'm going to call this list 1, and then I'm going to have another one, list 2. Okay, good. Now I can use the assignment operator for the initializer list to assign values to list 1. In this case, 2, 4, 6, 8, 10. And now if I run this, I should have 5 elements in list 1, 2, 4, 6, and 8. So 2, 4, 6, 8, and 10. And sure enough, we do. Okay. Now, I can also assign the values from list 1 onto list 2 using the copy assign operator. And sure enough, both list 1 and list 2 will have 5 elements, and those elements will be 2, 4, 6, 8, 10. And I can use the move assign. And when I do this, std move, now list 1 will have nothing in it, and list 2 will have the 5 elements, because list 2 has stole the elements from list 1. And sure enough, list 1 is empty, and list 2 has the 5 elements. Now I can swap list 1 and list 2. And to demonstrate how this works, I'll make list 2 have a couple elements. Let's say 99 and 100 and 101. And now I should have list 1 have those 3 elements, and list 2 should have the 5 elements because they swap places. And the last assign method we have is actually the assignment method. And here I can say list1.assign, and I can assign a value to list 1. And let's say I'm going to assign the value 3. I'm going to have 3 values of 1,000. Okay, so the list has many iterators: the iterator, the constant iterator, reverse iterator, and the constant reverse iterator. All right, to see how this works, I'll start with a bunch of numbers, 7 of them, and I'll say, hey, I want it to point to the first element, which is the element 2. And so when I look in the debugger, it is pointing to 2. Excellent. Now I can change the std::list int into auto, and that's much better because the declaration is really complicated, and that works exactly the same. Okay, now I'm going to advance the iterator by 2 slots. So now I'm not pointing to 2, but rather I'm pointing to 6 using the plus plus operator. And sure enough, I'm pointing to 6. Next, I can use the standard for loop to walk through the list, and this is what we commonly do. For it equals L begin, it not equals L end, and it plus plus. Now what I'm going to do here is I'm going to write, you can either read from the iterator using the star operator, or I can write to it. In this case, I'm going to multiply every element by 10, and sure enough, the values are going to be 20, 40, 60, 80, and so on. The list does not have the square bracket operator. We only have direct access to the front and back element, both for read and write access. Okay, so we're going to have the same 7 elements we had before, and what I'm going to do is I'm going to say value 2 equals L dot front, and that'll be the front element, and then I'll say value 14 equals L dot back, or the back element. So here I have read-only access to the list elements, the front and back of the list, and sure enough, value 2 has 2 and value 14 has 14. Now I can also modify the front and back. So this is going to be read-write access. And here I'm going to set it to the value 100. And then the back, I'll set it to the value of 9,999. And then when I execute the code, sure enough, the front element is now 100. And the back element is, in fact, 999. 3 main ways to add elements to the list are the push back, push front, and insert method. So I'll start with those same 7 elements in my list, and I'll say push front to the value 0, and I'll say push back to the value 16. And I should have now a 9-element list, 0, 2, 4, 6, 8, and so on, all the way up to and including 16. And sure enough, there's 0 and there is 16. Now, in order for me to add an element to the middle of the list, I need an iterator. So I'm going to say it equals L dot begin, which will point to 2, and then I'll say plus plus it and plus plus it, and now I'm going to point to the value 6. So I'm going to point to the value 6. Now I want to insert something at the value 6, so I'll say L dot insert, and I'm going to insert at 199 at the value 6. And let's see what happens here. You'll notice how when I execute it, does it go before or after the 6? It goes before the 6. Now I can insert not just a single element if I want, but I can insert multiple elements. So I'm going to change that 99 to initializer list, and I'm going to put the value, what should I do, 999 as well as 9,999. So now I'm going to put 2 elements in the middle of the list, all of them before 6. And when I execute the code, sure enough, I get those 2 values just before 6. There are 4 ways to remove elements from a list: pop back, pop front, clear, and erase. So I'm going to start with the same 7 elements I had before, and I'm going to remove the back element, which would be 14, and I'm going to remove the front element, which will be 2. It's important to note this is all done in constant time. In other words, if I do this with an array, I have to shift when I remove elements from the front, but with lists, it does it very efficiently. So now 2 and 14 are removed. I can also, I'm going to have my iterator point to the value 6 like I had before, and I'm going to remove that element 6. And so if I say L dot erase it, then it's going to remove element number 6. So now I'm going to 2, 4, 8, 10. And notice how there's 1 less element. All right. But now I can also remove multiple elements. So right now I'm pointing at 6, and I'll call that it1. And now I'm going to create an it2, which is going to start at 6, and then I'm going to advance it by a couple more, so it's going to now point to 10. So now it1 is going to point to 6, it2 is going to point to 10, and now I'm going to erase all the elements between it1 and it2. Notice how I'm not going to actually erase it2, I'm just going to erase up to it2. So it'll be 2, 4, 10, 12, 14. And of course, the last way that I can remove elements from a list is a good old-fashioned L.clear. And this will remove all the elements from the list, and so the size is 0. Sure enough. The list has 2 status methods, size and empty. So I'm going to start with the same seven elements, and I'll say S equals L dot size, and E equals L dot empty. And so I expect to have the values 7 and false. There we go, 7 and false. Now I'm going to run this code one more time, and I'm going to start with the default constructor, which means I'll have 0 elements in there. Therefore, my size should be 0 and empty should be true. And it is. To learn more about the list data structure, please take a look at C++ Data Structures by James Helfrich.